In this module, I discussed three concepts. The concept of CAPM beta, also called the CAPM beta, correlation, the correlation coefficient, and standard deviation, also called sigma. The focus of this module is actually to show the implementation of this calculation via a finance calculator BA2 Plus made by Texas Instruments. The CAPM beta can be estimated by running a regression with returns on the stock in question plotted on the y-axis and returns on the market portfolio plotted on the x-axis. So the independent variable is the market portfolio returns, and the dependent variable is the returns on the stock or the returns on the portfolio. The slope of this regression line, which measures relative volatility, also called systematic risk, is defined as the stock's beta coefficient, or simply beta. The basic market model, which is slightly different from the CAPM, because the CAPM has the risk-free component into it as well. The market model in the ex-post version is the return on a security is a function of the return on the market, and beta is the slope coefficient of the return on the market. So let's see how we can calculate beta using this finance calculator. So we have three sets of returns here for 3 years. The returns on the market for year 1, year 2, and year 3 are 15%, -5%, and 12% respectively. The return on the security for those 3 years is 18%, -10%, and 16%. It's important to keep in mind that the dependent variable is the return on the security, because the return on the security, according to the basic tenets of the CAPM, the capital asset pricing model, is a function of the return on the market. So that is the y variable, and the return on the market is the x variable. Let's enter this in our calculator. You hit second data, which is the alternate key under the number 7. So let's do that. Second data, and you see x01, which is prompting you for the first variable in the x vector. Associated with it is y01. So x01 is 15%. You hit 15. Do not hit the down arrow button right now. Hit the enter button. The little triangle here indicates that the calculator has accepted the value of 15 and stored it as x01, which is x1. Hit the down arrow button and you go to y01, which in this case is 18%. So you hit 18, enter. Once again you see the small triangle there, which means it's accepted. You hit the down arrow button. Now you have x02, so we do 5. Now how do you do -5? Is you use the toggle button here, plus minus, not the plain minus sign, it's plus minus. Hit enter, and the down arrow key here again. -10. So you do 10. See, I entered 100. On purpose I made a mistake. So how do you resolve that? You can use this back arrow or backspace button and eliminate one of the digits. So it's 10. You hit enter, down arrow. Alright, x03, that's 12%. Enter. And the associated value, so basically the return on the security in the third year is 16%. Hit enter, it's down arrow. It's important that when you hit the down arrow key this time, you'll see x04. Please do not hit the enter button there, because that'll register as a value of 0 for the fourth occurrence of the x variable. We don't want that. So continue to hit the down arrow button, and now y04 will show up as 02. Same thing, do not hit enter. See what happens now. It'll cycle back to the first occurrence of the x variable. That's 15. This is also a good time to cross-check our inputs. So 15 is mapped to 18. So when the market's up 15, the stock's up 18. When the market's down 5%, the stock is down even more. Actually, notice I have 10 here, whereas it should be minus 10. So the cross check was useful. We enter the minus sign there, hit enter, and so now you have minus 10. You have 12 and you have 16. Once again, 15, 18, minus 5, minus 10, 12, and 16. Once we are done with that, then we can invoke the stat function of this calculator. This finance calculator also has very useful statistical functions built into it. Hit second stat, which is second 8, and you see lin, which means it's in the linear mode. In case you're not in the linear mode, you need to hit second set to come back to the linear mode. So that would be second set, and it'll cycle through the various functional forms in there that are in there. You can experiment with it. You'll see exp, which stands for exponential, pwr for power, and so on and so forth. So keep hitting second set to come back to linear. But in case we are set at linear, so we leave it there. And now we use the down arrow button, and it'll basically spit out the calculations for us. As simple as that. N equals 3, so we agree on that. There's 3 sets of observations. Average x is 7.33. You think that's okay? Well, we can just do a back of the envelope calculation here. 15 minus 5, that's 10. 10 plus 12 is 22 divided by 3. That's 7 3s are 21. So it's about 7.33. That's right on the money. By the way, you see a little star here, which indicates that this is an output. Sx, that's 10.79. We'll come to that later on when I explain standard deviation and how to calculate that. And that's sigma x, that's population standard deviation. And then we go through the same thing for y, because we have basically 2 sets of variables here. So y is 8. The average value of y is 8. So 8 3s are 24. So this should sum up to 24. So 18 minus 10, that's 8. And 16 plus 8 is 24. So we're good on that. It's sometimes good to do these small cross checks. So I call them cross checks. To make sure that your variables are not flipped, xy. If xy is flipped, then all of your coefficients are going to be wrong. Standard deviation of y is 15.62. The population standard deviation, so the difference between S and sigma is the sample versus the population standard deviation. And now we are here at the CAPM equation here. So this alpha corresponds to this alpha here. So that's minus 2.59. And there's beta. That's what we were looking for. Beta is 1.44. So beta is 1.44. And that's your output of the regression here. So it basically means that that this particular stock is more volatile than the market. In fact, for a 1% change in the market return, we expect a 1.44% change in the return on the security. Now this can happen both ways, so it's not necessarily upward. So if the market is down 1%, we expect the stock to be down 1.44%, which, if you think about it, it actually means that it's 44% more volatile than the underlying security there, than the underlying market. So that's your beta. And our next related concept here is calculation of the correlation. Now I'm doing correlation here just because we've already entered the values in our data register, so it's just easy to show that. And beta and correlation, they are also related. The equation for the correlation coefficient is given as such. Now you can fire up something like Microsoft Excel, go to the help function, and that's where you'll find this equation of the correlation, where x bar and y bar are the sample means, average x and average y. And in Excel, you can also invoke the correl xy to give you this. If you want to calculate the correlation between 2 variables, you can use this Texas Instruments BA2 Plus calculator to get your correlation. After you get the beta, you keep going down, and your next output that is given by the calculator is R, which stands for correlation. So that's that. Correlation is bound. FYI, correlation is bound -1 to +1. -1 means perfectly negatively correlated. +1 means perfectly positively correlated. 0 is no correlation. 0 is an important correlation in the studies of financial markets because it's useful to have stocks which have low or zero correlation with the market to insulate your portfolio from excessive market movements, market-related movements. And the third item that I will show in this module is the calculation of standard deviation. The standard deviation is a very basic statistical metric, and it gives you an indication of the dispersion of your variable. This particular equation is what I call the probability-free version of standard deviation. It doesn't have probabilities in it because all states are assumed likely. The denominator is adjusted for degrees of freedom because 1 degree of freedom is lost because the average of the variable is already calculated from the variable values itself. So we are in the denominator we have n minus 1. So this calculation assumes a sample, and if you go back to second stat, you can go back on the up arrow key here. You see the standard deviation of y is 15.62, which is here, and the standard deviation of x is 10.79. Notice for the purposes of this discussion, we are looking at the standard deviation of the sample standard deviation given by Sx in your Texas Instruments BA2 plus, and not sigma x, which is the population standard deviation. In general literature, standard deviation is, however, just mentioned as sigma, so just keep that in mind. This concludes this particular module, which went over the concepts of standard deviation, correlation, and the CAPM beta, and their calculation via the BA2 plus finance calculator. This is Pank Agrawal, PhD Finance, giving you a tutorial on this topic.